Okay, so diving right in, about 3 weeks ago from tomorrow, we launched a new company, a new product called Pilosa. We launched it right before the big OSCON conference. Just in a nutshell, Pilosa is a new kind of database index. It's a distributed bitmap index. And just to sort of jump from there to something a little more contextual, as we all know, the last 5 to 10 years have brought tremendous advances in databases. We've seen a lot of new database types, from the traditional databases being put in memory or being put through exotic hardware, or new types of databases like graph databases. But at the end of the day, we believe that the database is really two technologies stuck in one body. There's the part that stores the data and the part that retrieves the data, which is commonly called an index, a primary or secondary index. And so what we're really opening the door to is the idea that we liberate the index from the storage and making it a first-class citizen in a data science-oriented technology stack and analytics-oriented technology stack, which is pretty much all of them now. And one of the important things about Pilosa is that it sits on top of rather than within your data store. Wherever you're putting your primary storage, that could be in Cassandra or in HDFS or Amazon's Redshift. We don't want to disturb that process. We simply layer on top, and we make your data faster.
I have actually in the past worked a lot more with some other database. I actually used to work with a very small database company based here and a few other things. And even though I had that job, I was still a little bit of a beginner with the technology. But so is this a sort of alternative to things like...
there are some Apache projects out there, like other open source technologies, that can solve these type of problems. Like one that comes to mind right away is a technology called Druid. I would say, but it's a very complex technology that is not easy to deploy and is really meant for other uses. So you could try to solve the problem with these tools. In fact, the motivation to build this originally came from using...
Yeah, exactly. Lucene and Solar, that's what I was thinking of.
Yeah, Lucene, Solar. So those are primarily used... Yeah, those are primarily used for unstructured data. So I think it's important to note that we're really accelerating already structured data. So it's the structured database index that we're pleading to pull out of the database. That doesn't make sense to be stuck in your database. And obviously, we want you to use our technology because we think it's faster than anything else on Earth.
Okay, so yeah, that does make sense. I mean, yeah, I think that's. I guess a lot of the databases that offer speed at the moment are generally unstructured. So it's interesting that you've gone from the structured perspective. I'm just trying to... I'm just having a very quick flip through your documentation I'm just trying to get a grasp of how you connect Pilosa to another database. How does that work exactly? What's the setup?
Yeah, that's a really great question. And I'll kick off and hand it over to my colleague Troy to explain a little bit more about how it works. But really, there's two types of data that you're going to connect yourself to. A large pile of historical data that's sitting in some data warehouse, data lake, database. So we have connectors into quite a few of those types of technologies. If not, it's fairly easy to write a connector into the database or data store of your choice. And then second, there's a lot of continuous arrival of data now that's coming in such massive volumes that it's also hard to process in real time. So Pilosa will tie into your data pipeline, things like Kafka. And as you're writing to your pipeline, you're also writing out to Pilosa to make sure that it's staying in sync and available to be sort of the primary place where you make your queries. So when you ask a question of a technology stack that has Pilosa in it, you ask those queries of Pilosa first because it is a whole lot faster. And then if it needs to go retrieve data, then it'll go back to the data store to get it.
And I think this is a good point, actually, so you have your own query language, the Pilosa query language, PQL. I mean, having a quick look at it. actually, no, I can't think of anything it looks like. So I don't know if that's a good thing or a bad thing. Maybe describe the query language a little bit.
Yeah, I was just going to add to that thought because I think you were going, into a good place. A lot of systems build things like a SQL front end, an SQL front end. We decided to stick to PQL for now because it is meant to go directly in your code, in your applications, and it makes it so much easier for a developer to access the underlying data quickly. So we don't ever really see an engineer or a developer querying Pilosa in any other language. However, on our midterm roadmap, we're considering a full ANSI SQL compliant interface into Pilosa so that things like your reporting tools, whether that's a Tableau or a Domo or any analyst tool, could very easily access the data itself. Although right now our primary focus is the engineer, not the analyst. So for now, we're really staying with PQL.
Okay. And I think this could just be the obviously the engineers you have in your team, but I noticed the client libraries are Go, Python, and Java. So there's no JavaScript. It's kind of a set of languages that are definitely used in a lot of particular use cases, or is it purely just because that's who you've got available to write the libraries at the moment?
Really, it's because that's what's available. It's been fascinating in our first 3 weeks launch, though, seeing how the community is now coming, into the mix. We decided to open source 8 of our 9 patents, and even over the weekend, there were tweets and all kinds of people starting to build connectors and contribute and fix bugs. Troy, you had some thoughts as well.
Oh yeah, we've got our roadmap is very long and wonderful, and we've got a developer working on a JavaScript client right now. It's just,
Okay.
So one of the reasons we chose to open source this thing, and I just pinged him on Slack to make sure I was getting it correct, and he said yes. So, one of the reasons to open source this thing is that we knew that it had a lot of potential, and that the community could give back to it as well and help to work on.
Yeah, the one we saw over the weekend is a developer is trying to integrate it with Swift.
Excellent.
And he said, do you have a Swift connector, or should I write one really quickly? And we wrote back and said, go for it. So he's writing a Swift connector right now. It's pretty exciting.
And I will say that.
Sorry, can you mention who that is? Just because I got a feeling there's one particular.
If you just look for our Twitter handle on Twitter. So just search for Slothware Mentions. And you'll see it. The guy's Twitter name is Binzi Hamid.
Oh, okay. Now, there's a particular company that seems to specialize in making, partially a company that seems to specialize in making Swift libraries for databases. I just wondered if it was them, but I can't remember. I think they're French. So,
but the beautiful thing for us, Chris, is that for our development team, that he reached out.
Yeah, exactly.
To us. It definitely is confirmation, because we measure ourselves in the success that we had on Hacker News and beyond. At the end of the day, though, it's we love all the. It was amazing. First of all, our ride the day we open sourced it was just incredible. Our developers saw just an amazing uptick, and since then, though, we're looking beyond those first day metrics and into how many developers picking it up and things. So to have that person reach out and was just an indicator of momentum for us.
I think this is kind of an interesting lead into my next question. So, I guess prior to OSCON, I had not heard of you. That makes sense because you hadn't really announced yourself. And then actually in the weeks afterwards, I have seen the name pop up now and again. I initially just said I was interested in speaking to you because I'd worked a little bit in, some other database companies in the past. So it was just interesting to hear some more. But I'm looking at your GitHub repo. Within 3 weeks, you have, a reasonable amount of forks, watches, stars, etc. And at least from the outset, you seem like a reasonably professional bunch. So I'm kind of interested to know, where have you come from and what was the origin story? Because it feels like you've sort of come out of nowhere to something, but there must be some more behind the story there about why you decided to start and who you are.
Yeah, I think there's a couple of thoughts there. Thank you for noting all of that. I'd say the success we had out of the gate was really, in my mind, twofold. I think it validated that there's a real problem, and that, our solution potentially solves that problem. Mindshare in this open source world and this big data world is probably the number one competitor, as we discussed earlier. So the fact that we could get that kind of attention out of the gate, and don't quote me on this, but, not knowing what we're really doing yet, we're just figuring it all out, is very, very reassuring.
In terms of community, we know.
Yeah. In terms of building the community, we don't know them yet. We don't know how they're going to react. So we're very pleased about that reaction. And, we naively started solving this problem for ourselves about 3.5, 4 years ago, because we couldn't find other tools to solve the problem. And we tried everything. And it was going to really affect our business. That company is called Humble, and it's a data management platform for sports and entertainment companies. We were trying to convince them that first-party data was the future of their business, and guess what? They sent it all to us. So we were having a real hard time processing all of that data, especially doing the real-time queries. So we started to build Pilosa, and almost immediately we recognized that if we solved the problem for us, we were likely going to solve it for everyone. And so from the very beginning, we worked really hard to code it in such a way that it would be easily extractable from Humble. And fast forward, 3 years, we've open sourced it, and we're excited to see where it goes.
Okay. That seems reasonable. So, I mean, Humble, obviously, I'm not in the States, so it's not a company I'm familiar with, but I get the idea now. I was sort of almost partially expecting, oh, yeah, we're all ex-Google or Facebook or something, But it seems a bit more reasonable then. It's a little bit more reasonable. So, I mean, on that note though, so there have been a lot of, there's not necessarily been projects doing exactly what you're trying to do, but there are a lot of projects trying to make databases, data storage, data management, data analysis better, faster to suit modern needs. Some have made it through, some have failed over the past few years. Like I'm still not, I think Cockroach is continuing, but then you had I'm having a complete mind blank over everything. Rethink came and kind of went rather unexpectedly. And even some other companies that I know here who have sort of made a splash and then kind of went a bit quiet. So, I mean, if this is something you want to make into firstly, is it something you want to make into a business? And if so, what's the idea? What's the plan?
Yeah, so I think that's a really good point. We did a tremendous amount of research up front before we made this decision. It doesn't come lightly, especially with 9 patents, under our belt. Convincing our stakeholders to do this was not the easiest of things, but we knew and felt that this was going to be so broadly applicable that picking any one application we thought would really be limiting the future potential of the technology. So while we'll help seed a few particular areas like bioinformatics, information security, smart cities, we can't wait to see where the community takes it. And then furthermore, when looking at the successful projects and the failures, we felt like we learned quite a bit from our predecessors. By no means do we have all the answers, but it seems like there's a 4-legged stool of components you must have to be successful. I think it's incredibly important what license you choose. We decided to go under Apache 2. We think it's incredibly important to nail a genuine community experience. You have to be developer and community first, or a disingenuous approach will kill you almost immediately. I also think it's incredibly important what investors you have on board, and we're working on that as we speak to bring on the exact right investors to make this successful. And then from a monetization standpoint, I think some people wait too long to sort of tell the community what they're planning on doing. We're trying to be transparent up front into working on those monetization strategies. So in addition to our community edition, we have an enterprise edition, and we're building a cloud edition, which makes us incredibly excited. We see ourselves in the next 5 years, caching 30% of the world's databases, and that's something that makes us very excited.
So actually switching back to technology, another thing I'm just trying to sort of pick up now. So when it comes to scaling, and I think I saw somewhere in some documentation about horizontal scaling, maybe. I guess that would possibly be accurate. But how do you how is someone going to scale the index alongside the database? Is it how easy is that to do? I'm not sure if I'm asking the right question, but
yeah, sure, you're doing great. So this is Troy, and we're both distributed and decentralized, and so the fact that there's no master and this thing you can horizontally scale on commodity hardware, the index proper, and what's important is that if you were to have a data lake or some sort of data warehouse that used commodity hardware, one of the problems with that is that it gets really either one of two things: either it gets really slow, or you have to sample the data as you pull it out of that. With our index, it takes these giant databases and makes them much smaller. And I think it'd be worth us in a minute spending some time on the secret sauce there. But by making that our index, first of all, smaller, but as it grows, it does horizontally scale. And the heavy lifting is the distributed nature of it.
Okay. And actually, sir, I'm jumping around a little bit here, but back to the query language again. There's obviously a few other databases, like I know you're not a database, but okay, other systems that you might query data from, shall we say, that have their own query languages, like Cassandra and Mongo. And there's a little bit of a learning curve to begin with to get those to work for you, and depending how you like them, they could work for you in the long run. How do you see the learning curve for Pilosa for learning the new query language? I lost my train of thought there, but I think you get the question.
Chris, I think that's a really great question. I'm going to start just by saying that I think it's a little bit less the query language and more the paradigm of creating your initial transformation into Pilosa, because once that's created, it's fairly easy to query. So it's really, you have to have this aha moment of understanding how do you take a traditional data set and create your index. And I'll let Troy talk a little bit about this bitmap index, which is really the key to Pilosa, the key to the speed, and the key thing that a developer needs to understand to really get it.
Okay.
Yeah, so is that a good tax take? Are you good with that?
No, I think that's definitely good, because whilst I'm familiar with the concept of index, I'm not familiar with what a bitmap index is. I know what a bitmap is and I know what an index is, but I'm not sure if they're the same connection.
You're doing great. And in fact, what's interesting is that, a lot of people have heard of a bitmap and have heard of an index, but we had this aha moment internally that this solved our problem. And it's so simple, but yet so wonderful. And that is, in a normal database, you would have, I would be a person in your database, and it would say that the kind of car I drove might be a Jeep or might be a Land Rover. And you would actually store that word Jeep or Land Rover. But in Pilosa, we don't store the word Jeep or Land Rover. We actually just have a table that has me in it, and I would be a column, and the Land Rover would be a row, and there would be a 0 or 1 saying if I owned a Land Rover or not. And in fact, Pilosa doesn't even need to know my name's Troy and that other row is a Land Rover. It just needs to know that there's a relationship there between two entities, and it's a 1 or a 0. And by boiling that down to 1s and 0s, you have this potentially infinitely large and infinite. The engineers tell me never to say the word infinite. 2 to the 64th, which is pretty damn close. But anyway, you can have a really large index of bits that indicate the relationships inside that original data store, and as a result, two things come out. Number one, it's highly compressible, because we're not a compression engine, but once we have all the information in 1s and 0s, it's highly compressible, and B, it's also a lot smaller, and you can hammer it with data science. And So that kind of tells you a little bit about the bitmap part of it.
And then just taking that a step further, you put it into ones and zeros, you compress it, it makes it very portable, as Troy discussed. But then we load it all into memory, so never does it run from disk. It runs all in memory, but unlike most in-memory solutions, it's also persistent across a cluster, a masterless cluster. So it's a distributed, decentralized cluster, so that you can basically scale this almost infinitely, again, to Troy's point, 2 to the 64th power. And it retains its speed. In fact, the bigger it gets, the closer it gets to linearity versus other databases start to just bog down and slow down.
And I'll rewind just to one comment earlier to lead back to your question, and that was comparing it to query languages and MongoDB. So once we used Cassandra at the last company, we really love it. It had some great attributes and the index set on top of it. Once you've made that aha moment of converting the data out of Cassandra into ones and zeros inside of Pilosa, you can now hammer the index with data science questions, as well as any sort of logical operations you want to do with it. And that's the aha moment where you use Pilosa rather than Cassandra.
Yep. Okay, I get it. So, you've already kind of touched on the fact that you consider some fairly wide use cases, but maybe give me an idea of the sorts of levels of data and the scale that, for example, Umbel, sorry.
Umbel, yeah, that'll work.
that was processing, and maybe some other people who have started experimenting with Pilosa and kind of the problems they're trying to solve and how successful they've been, if you have any yet.
Yeah, of course. On the Umbel side, at the end of the day, we were using Pilosa to solve some really high cardinality segmentation. So we had in the multiple hundreds of millions of consumers in the system with tens to hundreds of millions of unique attributes across those same users. So being able to quickly do a segment on the fly without pre-indexing or without batching sort of a process to analyze the data ahead of time was very, very difficult. And so that's really the original problem. But then being able to do sorts, top inquiries, and some much more sort of fine-grained analysis on that data became almost impossible with things off the shelf. And so from there, as we decided that this could go to the rest of the world, we talked about bioinformatics. We think this is going to be great for drug discovery. We talked about information security. Everybody wants to catch bad guys faster, and we think this is going to do it tremendously faster. And then on the smart city side, we were recently working on a transportation data set of New York cab rides. We got 1.3 billion records that had about 100.
It's a classic data set, isn't it?
That one. It had about 100 columns, and we wanted to just see how we compared to all of those benchmarks using commodity hardware. So by the time it went through that abstraction process that Troy talks about, we turned it into ones and zeros. It went from 100 columns to 100,000 columns. But then it was in a very lightweight, super nimble bitmap format. And as we started to ask queries of it, the only technology that it ever benchmarked against it that came close was a 8 GPU cluster, very exotic, very expensive hardware, while we were using off-the-shelf commodity cloud hardware to do the exact same thing. So that got us incredibly excited. And it's not that we don't plan on using some of the exotic hardware for certain use cases, but we think the low-hanging fruit is to be able to use commodity hardware to solve some of these huge problems where, the economics aren't there to throw GPUs and FPGAs at the problem.
Exactly. I think this has been a trend in some of, especially the scalable databases I've seen, and especially the sort of advent of contemporary containerization, shall we say, has meant that the ability to run massively scalable systems on more commodity hardware, what we consider commodity hardware now, I suppose, has become increasingly possible, I guess.
Yes.
I don't know if that says more about the hardware than the software, but I'm not sure.
And some of this new hardware is unbelievable. So, as we get into some really intense use cases with, the U.S. government or large financial institutions who want to catch bad guys and have the resources to do so, of course we're excited to try that commodity hardware, that exotic hardware. But right now there's just so much opportunity in the off-the-shelf, cloud hardware that, we'll try that later.
Okay. So just out of interest, I'm trying to think of what an average data set would be, but what sort of storage size and minimum kind of hardware do you think you would need to run a Pilosa cluster, and what's the kind of the storage it would take up on top of a data set? Whatever numbers you can think of would be useful, I suppose.
Yeah, so we've had a number of initial Lighthouse clients approach us, and one of our first questions to them is, what size is your data? And often it comes in two answers. Number one, the actual data set, we usually just simplify it and say if it's over a terabyte, we can start to help you. But it's also a high cardinality issue. It doesn't have to be necessarily a large data set, which is great, but also just high cardinality, the number of rows. And so those two, when you get to hundreds of millions of rows, we start to really, really kick in. So does that answer your question okay? And then there's also just the order of magnitude. Usually we can reduce the data size by at least an order of magnitude, if not more, when we start to reduce the size.
Okay.
Yeah.
Okay. So what you add with Pilosa, you actually remove from the storage, I guess.
Yeah.
Is that what you're saying? Yeah.
Well, we don't take. Let me make sure I understand your question. We're not taking the data out of storage and we're capturing the relationships that are already there. But yeah.
Okay, so you are adding to. Okay, so you're adding an extra bit of storage to the storage. If that makes sense in terms of actual disk space.
The benefits to speed
of course,
having to sample. Yeah.
Of course. Just a sort of a slightly tangential question in kind of leading to a wrap up, just because I'm kind of interested. So you have you've released, as far as I can tell, your core and SDKs and et cetera libraries on GitHub, but you mentioned that you have patents as well, and I'm kind of interested to know how you manage to combine patents with open source. I mean, the US is much more into patents than Europe, so I'm not so familiar with how you might be able to do that. Maybe it's a very obvious question, but I'm kind of interested to know how you can have patents on a software but also be open source.
Well, that's a great question.
How do you balance the two?
Apache 2.0 has just a patent clause that just says we're not going to go out and sue people or just try to get the rights on those patents if you are using our open source software. And there's a few exceptions to that clause. If they come back and try to sue us for it, then that revokes that clause. But basically, it's we don't focus on the patents too much in the open source community, only because they might seem antithetical. But the beauty of it is that we've by open sourcing by default in the Apache 2.0, those patents and the intellectual property within them are now part of that contract we've made with people that we're not going to go out and enforce them.
So effectively, we've conveyed 8 patents to the Community Edition, which we're really proud and excited about. There was a lot of internal discussion about which patents and where exactly we would sort of cut the line between Community Edition and the commercial editions. And we ended up choosing a very liberal strategy in favor of building a really healthy community.
Okay. That's cool. I mean, I've always been into open source and contributed to open source as much as I can. It's something I've always supported, and very big. Yeah, I think the past companies I've worked for have always been, at least, yeah.
Yeah, and we do think, we're excited about the impact and the contribution we're making But we also really do believe that the future of enterprise IT depends on being open source. So I think it is going to be the way of the future for these type of technologies, whether you like it or not. So I think, finding a good strategy and doing it early is important.
I think so too. Actually, this evening I had an interesting discussion with someone who works for a sort of, I guess, small to medium-sized startup, and he was telling me about his experiences with a very large, well-known enterprise company. In fact, probably beyond enterprise company, and just how it's always this weird clash of cultures where you can't quite understand why do you not want to tell people things. At some point in the future, I think this is going to be a sticking point for companies that just want to hold everything to their chests. I think the world has changed, and if we have companies like Microsoft able to do it, then to a greater degree, not entirely, but to a greater degree.
Having just come off of OSCON, we can validate your statement that there were plenty of larger corporations there, and the conversations weren't awkward. In fact, that's how can we work together. And so I think the time is now. It's just that the dinosaurs don't get it yet, but there are a lot of even very large corporations that get it.
All right. So what's your current kind of version roadmap? What's coming next? What's your immediate plans that you want to make sure people know about?
We're all about first of all, we're all about building community right now. We know that that's the life of blood of any open source project. We're also not naive that we need to build out a business model that can support it on the other side, and so we're working on enhanced enterprise features on top of that. So that's in a bucket. That's the two big things.
And I would say on that one, the one that gets me really excited is this Cloud Edition version. I talked about my big audacious vision earlier, but I really do see a world where you're sitting on a really giant data lake, assume it's HDFS or something like it. You need speed and you don't have time or the team to deploy and manage all the infrastructure. You add a few lines of code, you log into a console, and now, your index is available globally, in real time to all of your applications, your researchers, your partners, your customers. And so that as a service, fully managed version of Pilosa is the one that I think is going to be really, really impactful.
Okay. I kind of I look forward to seeing what you do.
Thank you.
Yeah, I guess I have a place in my my technical heart for kind of large-scale databases, having sort of briefly worked in it a little bit and just seeing what people do with it. I think maybe last year was the crazy year when lots and lots of new projects came out, and some fell by the wayside. So it's interesting to see where they managed to go. And actually, I suppose just on that note, just for anyone who's interested in you've written this in Go. Actually, it wasn't intended as a pun, going from Go to Go, but
we've definitely
written it in Go.
It was deliberately written in Go, and Go has an interesting feature that has plug-in features and functionality that we've built into the product so that data scientists and those who work in that field can plug in algorithmic applications with ease, which we think is going to be a big deal. And plus, when you get to really large code bases, Go is just so wonderful. We're big advocates of that.